Okay, so this is question 4. My name is Mujahid Chima. So we have to prove or disprove that if A equals B in probability and P equals A equals P, probability of B equals probability of AB, then A equals B with probability 1. Okay, sounds like a mouthful, but it's pretty simple. What we have to prove is that, okay, so if probability of A B not plus plus A not B equals 0. If this is true, then A equals B with probability 1. Alright, so let's assume this condition. Let's assume that P probability of A equals probability of B, which equals the probability of AB. And let's work with the definition. Okay, so starting with the definition, we can rewrite this whole thing as we did in the previous example, question number 3. We can rewrite this as 1 minus the probability of A B naught plus A naught B, the complement of that whole thing, equaling 0. Alright, and then we can just, add the 1, take the 1 to that side, and we can write this as probability of A B naught plus A naught B complement equals 1. Okay, now we're gonna start using De Morgan's law. We can rewrite this as the probability of A B naught complement times A naught B equals 1. Okay, so using De Morgan's law again, we can rewrite this as the probability of A naught plus B times A plus B naught equals 1. So now we can just multiply through, like FOR this out, whatever you want to call it. It'll become probability of A naught A plus A naught B naught plus B times A plus B B naught, all equaling 1 still. The probability of A and the probability of A not happening, the intersection of an event happening and not happening is always the null set. So this and this is the null set. So it just simplifies to the probability of A naught B naught plus BA equals 1, which we can rewrite as the probability of A naught times B naught plus probability of B times A minus probability of A naught times B naught B times A, which equals 1. Here now we can see that, okay, so if we FOIL this out, it basically means A naught times B naught times B times A, which is basically A naught times A times B naught, which is just the null set. So this whole thing is just the null set. So we can get rid of this, and we are left with probability of A naught times B naught plus the probability of B times A, and this all still equals 1. Just use De Morgan's law again. We're gonna have, that's an important law, as you can see. Use that a lot in these proofs, so it's good to get familiar with that law. Plus the probability of B times A equals 1. Now let's rewrite this as 1 minus the probability of A plus B complement, which is just probability of A plus B, plus probability of B times A, which equals 1. And alright, so we can rewrite this whole thing as 1 minus probability of A plus the probability of B minus the probability of AB plus the probability of B times A. This all still equals 1. Let's negate everything. Take this negative sign inside. Open this up. 1 minus probability of A minus probability of B plus probability of AB plus probability of BA equals 1. Alright, so now we can see that probability of AB, which is the intersection of A and B, and the probability of BA, which is the intersection of BA, it's the same thing, so we can just rewrite that as 1 minus probability of A minus probability of B plus 2 probability AB equals 1. Okay, so now we can start using our initial condition, which was that we assumed that PA equals PB, which equals PAB. So let's write, since everything is equal, we can write it all in similar terms. So let's just stick with PA. So minus PB, that just equals 1 PA, and 2 PAB, that equals 2 PA, which equals 1. Let's see what cancels out. Minus PA, 2 PA, these cancel out. So 1 equals 1, which is true. So the proof is complete. Proves our initial condition that PA equals PB, which equals PAB. It holds if this is true, this is true. And yeah, that's it. Thank you for watching.